Crewton Ramone's House of Math, playing fractions with Popsicle Boy. Alright, so let's do some review quickly.
Okay.
So we start off just playing with equivalent fractions, right?
Yep.
And we know all the names of the parts, right?
Yes.
What's this part?
Numerator.
Well, what's this part?
Denominator.
Uh-oh. Am I not on the screen? Alright, it's barely off. Alright. Do you know what this part is called? Just for fun.
The fraction line?
Nobody cares. It's either the vinculum or the solidus. Depends on
Okay.
how it is. Some people just call it a slash. But anyway, alright, so numerator, denominator. So let's see here. And then we figured out that, 1/2. If this is 1/2 and this is 8, what does that have to be? And these are going to be equal.
16.
Gotta be 16. Right? The relationship is 1 to 2. Good job. Alright, let's get crazy. Let's get totally
8
nuts.
plus 8 equals 16. I did 1 times 8 equals 8 and 2 times 8 equals 16.
Same. Perfect.
I can equal 2. 1 plus 1 equals 2. 8 plus 8 equals 16.
Alright, that's an excellent concept. I like it. It's a good way to look at it. Oh, so what if I had something like crazy like 37? Then what?
Oh. 74.
74, good job. Alright. Now, what if I'm not so cool and I do like, say, 7 over, what could I do? 7 over 12 is the same thing as 21 over what?
No, it glitched. Okay. 21 over what?
Yeah.
36.
Over how much?
36.
So you are correct. I gotta zoom out, apparently. Keep not being in the right spot. There you go. And it's... Is it straight up? I can't tell. Alright, that's as good as it's gonna get for these guys. Alright, so 36. Why?
7 times 3 equals 21. 12 times 3 equals 36.
Beautiful, because what are we doing, right? Our 1 is 3. Right? 3 over 3. Alright,
Yeah.
Excellent. Alright, so now, let's see if I have... Okay, so we got our equivalent fractions down. Let's do some conversions with whole number... Oop, you're frozen.
Nice.
You're frozen?
Like frozen? Like frozen or like frozen?
You're frozen. I can hear you, but I can't see you. Well, I mean, I can see you, but you're frozen, eating your popsicle. Okay. Yeah, I don't know, my computer glitched or something. Alright, what we're doing, I was just about to say, we can do a couple of things. Let's do this. How about, I like it, I know, you're getting almost, you're what, about halfway through your popsicle?
Yeah, probably.
How about, what if I say I have, just so you remember how to do it, if I have 2/3 plus 3/5, what's my answer? I've got 2/3.
Can I run and solve it?
Yes, absolutely. What are you doing?
I'm solving it.
I know, but what are you doing? I know you're solving it.
I'll tell you after I'm done.
Okay, fine. Don't talk to him while he's thinking. I can see your pencil working furiously.
The answer is 19 over 15.
19 over 15. Okay, how'd you get 19 over 15? I'm going to multiply this one by...
3 and 5 can both go to 15.
Alright, I like it. So you got a common denominator of 15. I like it.
3 times 5 equals 15, and 5 times 3 equals 15.
Right.
So
Your 1 was 5 over here, 5 over 5, and over here it was 3 over 3. So over
but
here,
2
you
times
got
5.
9, and over here you got 10.
So 2 times 5 equals 10.
Bam.
And 3 times 3 equals 9.
Bam. And then you added them together. And uh-oh, we have what kind of fraction?
An improper.
So what do I have to do now? You've come a long way. I think we had, what, 2 hours of fractions? And you can already pretty much handle all this stuff, no problem. All right, so what do I have to do?
Make it proper.
Okay, yeah, we're going to turn into a mixed number, right?
Oh.
Do you remember how to do it?
I didn't practice that.
No, I know, but that's the idea. We're getting it in steps, right? What's the next thing? Because that was the next thing we were going to do. I was going to actually go to mixed numbers and stuff, but I thought, well, you know what, let's go to mixed numbers by doing some addition of fractions first. All right, so how many 15s in 19?
How many? 1.
One of them. And what are we counting by? 15s, right?
Yeah. Okay.
And if I count how many 15s are in 19, what's left over?
4.
Are we done?
Yes.
There you go. So you can take your blocks out. And I could have...
Mama?
And
Mama! No blocks again.
Oh, no blocks?
Yeah.
You don't have blocks?
She said next time.
Alright, next time. Hard to do math classes like this without blocks. Alright, so there's 19, and all we're doing is counting how many 15. What does 15 tell us?
15?
Yes.
Is the what kind?
What kind? I like it. Tells us what 1 is. Right?
Yeah.
So now I can see that, yep, there's 1 of them in there, 4 left over, and we're counting by 15ths. In fact, I could do it again. You see, I have my, let's move this guy over, book. Alright, there's my 15 there. And if I was counting it out, how much would I need? Oh, jeez. Somebody needs more glue. Alright, how much would I need? Well, I need 1 of them, and then I need 4 of the next one. Let's get smaller so it makes it easier to see. In fact, let's just get rid of the 10s and play with 5 and 9. What do you say? Anyway, fine job. So let's do and convert just plain old, oops.
This time I think I can convert it.
Over 5. What's that?
Oh, I have to convert it?
Yes, to a
so there's
mixed
5,
number.
There's 1, 5, and 9.
Yes, there is.
So 1.
Yep, so 1. Because that tells me what 1 is. How many? Every time I get to 5, that's 1. Do I need all the next one? Do I have 2? No, I don't have 2. I only have 1. And how much of the next one do I need?
4.
4
so
of it. Yeah, so it's... He's busily eating his popsicle trying to do math at the same time.
4 over 5.
Yep, 1 and 4/5. Make sense?
Yeah.
And now you got to the strawberry part. Which was better, the strawberry part or the mango part?
I don't know. I have a question. Say if it was say 15, right?
If it was,
15 over 5.
okay, yeah, if it was 15 over 5, what would that be? That'd be super easy.
Then there would be 5.
Wait a minute, 15 over 5, just think for a second. What is it going to be?
There would be 3 5s and 15.
That's it, and you're done. So what would
So
it
then the
be?
numerator, wouldn't the numerator,
There wouldn't be any numerator. You could just, well, I guess you could have a numerator if you really wanted to, but you don't need a numerator.
And the denominator?
The numerator would be 3, technically. But how many 5s in 15?
How many 5s in 15? 3?
That's it, you're done. Now, I could say that that's the same thing as 3 over 1, but that's ridiculous.
Yeah.
Right?
Because it's so improper.
Right. So bam, it's just 3.
It's just 3?
Isn't it? Isn't 5 contained in 15 3 times?
Yeah, so only if it's 1 you have to do the rest of it.
Well, now let's say if it was 16, now what?
Now it's 3. Oh, 3 and 1, so it would be 1 over 3.
Well, hold on a second here. Try again. Count. Look over here and count. I know you don't have blocks, so you have to look on the screen. Look. How many 5s are in 16?
3.
3. How many left over? Because I can't count 4, can I? I can't count 4 of them. I can only count 3 of them. I don't need all of this one. I only need 1. Out of how much?
Out of...
What were we counting by?
5.
5s. So what would my answer be? Please tell me.
1 over... Oh, 1 out of 5.
Try again. I want the whole answer.
Oh, 1 out of 15.
Try again. I don't have a 15 anywhere. 16/5 is the same thing as what?
1...
Not 1.
3.
And?
1.
And? What am I counting by?
5s.
There you go. Sit and think
I
for
said 5.
I told you to give me the whole answer. So what are we doing here? Tell me what I'm doing here. I'm counting, but what am I counting? That's the important part.
Wait, I have a question.
Good.
What is the 3 for?
That's what I'm asking. There you go. What does that 3 mean?
What does that 3 mean? What does that 3 mean?
All right, so answer my question then. What is this question asking?
Asking, what is the lowest common fraction of 16 over 5? I mean, make it a mixed number.
Make it a mixed number, okay, but what is it asking?
16 over 5.
What's it asking? It's asking how many 5s are contained in 16. What are we counting?
Oh.
What are we counting?
So 3 is the answer, and then there's 1 over 5.
3, the whole thing is the answer.
Oh.
Alright, let's try again. So, answer my question, child. How many 5s are in 16? Let's count them. 1, 2, 3. Oops, there's not 4.
No.
There's only 3. And I need 1 out of those 5s. What am I counting by?
You're counting by 5.
I'm counting by 5s. Right? So basically this is a division problem, isn't it?
Yeah.
I mean, it's the same thing. So what I have here is I'm just converting this improper fraction into this mixed number. Does that make sense? So
Yes.
I gotta know what I'm counting. I gotta know what I'm counting. And what I'm counting is 5s. 3 is the number of 5s. And 1/5 is also the number of 5s, but it's only 1/5 of a 5. It's not a whole 5, it's a part of a 5. That's why we call them fractions. Parts of numbers.
Now I get it.
Alright, great. See? And that's what I mean. You gotta sit there and think about it for a second. Now, you wanna give me one?
Sure.
Alright, give me one.
How many...
Oh, just give me a number. Give me two
Right?
numbers. Yeah, well, just give me 2 numbers. A big number and a small number.
A 7.
Okay, I
and
like it.
22.
7 and a what?
22.
That's not an improper fraction. I could do 22 over 7. How about the other way around? 22 over 7.
Oh, 22 and a 7.
Yeah, so we'll do it the other way around. 22 is my numerator, and 7 will be my denominator. Okay, that'll be an improper fraction.
Mm-hmm. I figured it out.
Alright, what do you got? Tell me the answer.
You have to answer it.
Oh, I have to answer. Alright, so here's what I'm going to do. I'm going to go about it the slow and laborious way because we're making a video. Otherwise, we just do it fast. But alright, since we're making a video for other people to hopefully learn something from this. Let's see here. What do I got here? I got to get 21. No, wait, I gotta get 22. And then what am I gonna measure my 22 with? Tell me, what am I gonna measure my 22 with?
With 3 sevens.
With with 3 sevens, you're right. Actually, I need 4 sevens. But technically, there's only because there's gonna be a part of a 7. But you're right. There's no way I can fit them all in there. I'm just gonna have one of them.
Answer. I can't hold it in for much longer.
Okay. No, I have to do it. All right, so bam, there it is, right?
Yeah.
All right. So how many of them? Well, you're right. I needed 3 of them. 1, 2, 3. But I didn't need all of this one. I only needed 1 of it, and I was counting by sevens.
Yeah.
Is that the same answer you got that you couldn't hold in?
Yes.
Okay, good. All right, I'm gonna give you one now. Ready?
Yes.
In fact, you know what? Have you got your dice handy?
No, I think I only have 1 8 dice.
You have 1 8-sided dice?
Yeah.
All right, that's sad. All right, I'll just make up a number then. How about 25 over 2?
25 over 2.
Yeah.
If I had my blocks, it would be so much easier.
I know, but let's just think about it. How many 2s can you count out of 25? I mean, for sure you can count 10 of them, right?
12.
12, I like it. Closest number you can get to 25 is 12 times 12 times 2 is 24, 2 times 12 is 24. What's left over?
Yeah, because there's 12, so there's 1 out of...
What were we counting by?
2s.
There you go, done. Can you picture it in your mind? When you get out two 10s and a 5, and then I'm not going to do it here. We're going to use our imagination. And see if I had some. I got a little boy who's working on figuring out how to do animations. There's that. There's that. See it? So what do? We counted out 1, 2. We had to get 12 of them out, and I'm not going to. And then when I got to the very end, I'd be to 24 right there, and I wouldn't have. If I had 26, it'd just be 13, right?
Uh-huh.
But since I have 25, it's 12 and the half of 1 right here. See it?
Yeah.
Alright.
Yes. Wait, I also have another.
Wait. We have 2 more things to do. You said your mom taught you multiplication, which is super easy, but I'm going to show you some.
Never mind.
I'm going to show you some stuff. But wait a second.
I have a question.
Do you have a question?
No,
right.
I figured it out.
Alright, what was
it's not
that's the best kind. When you think you have a question and then you think for a minute and then you answer your own question. That's the best kind. What was the question that you had that you just answered for yourself?
If it was like 3 over 3, that was...
Well, 3 over 3, what would that be?
It would be 0.
Oh, hold on a second.
No, 1.
Yeah, there you go. Big difference. How many 3s are contained in 3?
1.
There's 1 3 contained in 3, right?
Uh-huh.
And that's the same thing as 1. It's a very important identity right there, actually.
Mm-hmm.
You can take any number, divide it by itself, and you get 1. All right. Now.
Wait, is 1% 3 over 3?
1%?
Yeah.
Let's think about that for a second. What do you think?
No.
You're correct. Okay, how about... Oh, what if I change this? Since we got the 3s up there, I'll use my imagination again. Instead of using 2s, I'm going to use 3s this time. So what if I had 25 over 3? Now see, with a lot of kids, I use fractions like this to teach multiplication and other stuff, but you already got that stuff down, so we're not going to spend a lot of time on that.
So it needs 8. 8 3s.
8 3s, and what's going to be left over?
1.
Again, and what were we counting by?
3.
There you
so
go.
It's 1 over 3.
So it's 8 and 1/3.
Yes, 8 and 1/3.
So 25 over 3 is the same thing as 8 and 1/3. All right, now let's go the other way. Let's go the other way, just for fun. What if I had? So now I'm going to give you the mixed number, and you're going to give me the improper fraction.
Oh.
Okay.
Yes.
All right. Are you ready?
Huh?
It's taking you a heck of a long time to eat that. I've never seen anybody take so long to eat a popsicle. It's awesome.
You know, like stuck at the bottom.
I can tell you're enjoying it. Yes, it's good. All right, so what if I had 7 and I don't know 3/8? Give me the mixed number.
You mean the improper?
That's what I meant. The improper, because I gave you the mixed number. You have to give me the improper fraction.
Can you give me the steps how to do it?
I'm not telling you. Figure it out. We've been doing so many of them. What would you have to do?
Oh, wait a minute.
What were we counting by?
Oh, 3 over, is the answer, you were counting by 8s.
How many 8s did I have?
7.
So what am I going to do here?
8 over 21. It's 21 over 8.
You think it's 21 over 8?
Yeah?
Alright, let's see. If I had 21 over 8, that would be the same thing. How many 8s in 21?
8 and 21? 3.
3 times 8 is 24. We went over.
2.
2. Alright.
2.
And what's left?
1. I mean, no, 5.
Mm-hmm. And we're counting by 8s. These two numbers anywhere near similar?
No.
Alright, so what am I going to have to do?
I mean, they are the same kind.
They're the same kind. They were doing 8s, but I want the improper fraction for 7 and 3/8. What am I going to have to do here?
There are 7 8s, right?
Well, how many is 7 8s?
56.
Alright, well now we're getting somewhere.
Oh, 56 is the numerator.
Is that going to be enough, or do I have to add some more?
Oh, the 3, so 56 over 3?
Wait a minute. I'm adding.
Oh, 59.
Why would you divide by the 3?
No.
That's what I'm saying. I can't even think why.
Add by the 3.
Alright, so you add the 3. Alright. So you get 59. Alright. And what were we counting by?
We were counting by 8s.
Did you get the right answer? You can check it, you know.
I know I can.
Alright, so is it correct? So what makes me crazy when my students come back to me and tell me they don't know if they got the answer right or not? It's math. How do you not know? All the way up to calculus. I don't care.
It's correct.
It is correct. There are 7 8s in there, which will give you 56, and then there'd be 3 left over, and there it is.
Mm-hmm.
So what do you got to do? Tell me what you have to do.
So first, you have to do 8 times the 7 in this case.
Yes.
Plus the 3, the numerator.
All right, so here, look, here, draw this on your notepad. And see, he told me,
okay.
I did not tell him. Some of you need to understand this simple concept. All right, so 8 times 7, then I add the 3, right?
Wait, I'm writing it down.
And we went this way, clockwise even.
I'm gonna write okay, that's good. There.
Let's see yours,
It's the one
You have
below
managed to make a popsicle
the
last
middle
for 35 minutes. I am impressed.
Oh, my Mac is gonna sleep soon.
I have a friend. Well, then touch the thing. Okay, yes, I like it. All right, so you understand this times that plus that over that. That's what that is, right?
Yep.
Hey, we're moving along quite nicely. We haven't gotten the multiplication and we haven't gotten the division yet, but I think we'll get the division soon.
Or maybe we'll do the whole time.
We'll see. Here's the deal. You want to master stuff before you move on to new stuff. It's as simple as that. So when you exhibit mastery, that's when we move on.
Yeah, I'm saying we might not.
And you're getting there. And see, you've already pretty much mastered your multiplication. We got to work a little bit more on the multiplication in the teens. I know this because you haven't practiced, but you definitely practiced your single-digit multiplication.
Today I placed a I practiced a little long multiplication.
Good. What? Long multiplication? Like what?
Long multiplication.
That's what I mean. Like what? What kind of numbers?
Like the one that you told me to do?
Like 3-digit times 2-digit?
No, 2-digit times 2-digit.
2-digit times 2-digit. All right, let's just say 2-digit times 2-digit under 20, but we'll get to that in just a second. Let's practice a little. Just practice this just a little bit more before we move on. What do you say? I'm gonna use this. I'm gonna use this as my, so I know where my borders are on my other camera, so I can see that high and I can see that low. Okay, and I can see all the way. Whoa! I can see all the way over there. Holy cow! All the way over there. Okay, a little more even. Okay, and then.
I don't think my Mac is gonna make it because there's only 2 chargers left.
We'll plug it in.
I'm not sure where the charger. Oh, I think this may be the charger.
Yeah, just plug it in. You are silly.
Yeah, this is the charger.
It won't die if you plug it in, promise.
I know, well, I just didn't technically know where the charger was.
Alright. Now we're happy. Are you? Oh, yep, but I just saw the thing glow, so yes, we're on. Okay, so let's practice just a couple more of these. I'm going to give you a few more.
I'm gonna put the wire. Wait. Can you just wait a little? I'm gonna put the wire over the computer.
Yeah, there you go. Put it in the back of it. I like it. Okay. And while you're doing that, I'm gonna give you a couple of these. All right. So let's see here. I'm gonna get crazy so that we can do both. We're gonna practice, like, say, what is 17 and 5 twelfths? Oh, look, you gotta multiply. Let's see here. What is let's do 15 and 9 thirteenths. Ooh, there's a fun number. How about 16? Oh, look, 17, 15, 16. Huh, we seem to be practicing something. Let's see here. And 12, 13. I guess that's going to be 14. And we'll make this number fun, though, and we'll make it like 11 fourteenths. All right, 3 problems. You're on.
Okay, 3. So 17, 5, and 10.
Just finish your popsicle.
It is.
That is 40 minutes of popsicle sucking. I'm impressed.
I mean, I think there might be a little left to drink, but like, it's kind of stuck.
You're kind of stuck at the bottom? Well, use your finger to get it out of there. And it wasn't even that big of a popsicle. I mean, that was a monstrous popsicle. I could see it, but that was not even that big of a popsicle. But it's summertime.
Like
Summertime is a great time for popsicles, isn't it?
Yeah, for 20 minutes I was like halfway, and for like 20 minutes I was like right here. So.
Anyway, all right. Put your popsicle down. You know what you could do? Put your popsicle down and maybe go wash your hands, because I can see you're a little sticky.
There, down.
All right. There's a bathroom nearby, isn't there?
There is one.
Just go rinse your hands off and so forth, so you don't get your math tablet all covered. And he wipes it on his shirt. I love it. You might be 7. Anyway, go run over to the bathroom and just rinse your hands off on fast one. Oh dear.
Done.
All right, and then dry your hands.
I did.
So you don't get your math book soggy.
Yeah, I did.
That was fun. You just appeared. There was a glitch in the thing, and the chair. You weren't there, and then all of a sudden you were there. You're like magic. Okay, go ahead.
Okay.
Pencil and paper.
Pencil and paper. Okay.
Okay, now if you knew 12 times 17, bam, we'd be already almost there. But you got to practice because you don't know 12 times 17.
No, I do.
Oh, what is 12 times 17 then?
Wait, let me just finish writing.
Okay.
I just asked you.
I know, okay. I believe you.
It's 204.
I like it.
Plus 5, so 209. 209.
I got it. And then what?
You froze.
Okay.
So I couldn't hear you or anything.
All right. So anyway, 209 over what?
Wait, I need to write 209 down. Over 12.
That's it. Done. That's the easy part. 12 times 17 is how much?
12 times 17, it's 200, it's 204.
And then you added the 5. All right, good job.
In this case, it's
All right, 'cause
205.
look, it's 170 plus 34. 204. Good job.
I'm actually happy that instead of making the easy part hard, I actually made the easy part easy.
Yes, I like it. We're getting better on that end of things because you tend to try and make it as hard as possible. So what's 13 times 15?
13 times 15? Oh wait, I need to write that down on the next page.
Oh, you ran out of space. Okay, go ahead.
That's too little of a spot. There's a little spot, like, I don't think it's big enough.
All right.
Nine and 13?
Wait a second. What's 13 times 15?
Is it 9 and 13?
Yes, it's 15 over, what, 15 and 9/13. What?
Okay, wait,
Telling me
I'm
you can't
writing it
read
down.
my writing? Is that what you're trying to say?
No, I'm running, yeah, I said 9,
That's
yeah,
a 13.
right.
What? Fine, I'll make it. Here. Be like that.
15.
Alright, so what's,
9,
let's see, so it's 150 and 45.
wait, there, so 13 times 15 is 100, 3 times 5, 180, 195.
195 plus 9.
It's 204.
204, like it a lot.
Which is.
And you're done. You're done. What do you mean you're done? You did the hard part. Everything is done.
Which is 12 times 17.
Oh, I like it. 12 times 17 and 13 times 15 are the same number? Not.
No, plus 9.
Oh, plus the 9. Okay. I like it.
And then 13 on the bottom, obviously.
I like it. All right, this one. This should be
16, 11, 14, got it.
This should be super easy. What's 16 times 14? That should be one of the ones you know.
Wait, I'm going to write it down first, because writing down always helps.
Good.
So, 100, 200, 224.
Uh-huh.
Plus 11, so 225, 235.
Yep, 235.
And 14.
And we're counting by 14. Oops, there we go. Bam! Look at you. Fine job. Now look, we're doing fractions and we're doing multiplication all at once.
Yep.
Why just do multiplication when you can do fractions too?
Yes.
I agree. All right, so, want 3 more? You did those very well, by the way. I'm quite pleased with you.
Yeah, but I know the rest of the time is bad, because the charge is helping.
Yes, the charger's helping. Good. Mine too. My computer is now back up to 100%. All right, so let's
Mine's
go.
at 4.
Where you're
But
at?
it's still going up.
You're at like 4%.
Yeah, but it started at 2, so it's still working.
So it's going up. Yeah, there you go. It's not going down. All right, I'm gonna give you 3 more of them, and we're just gonna practice our fractions and our multiplication. All right, there we go. So let's see here.
Can we do the rest of it for 19 minutes with it? With doing this?
If you want to. It's too
Yeah, I
easy.
want
It's
to.
a little
This is
too
fun.
easy, but all right. Okay, this is fun. All right. You know why it's fun? Because it's easy, and you know what you're doing. I like it. Okay, so let's do something crazy like I don't know, 19, and because we got to practice up there. 19 and 6 13ths, and then how about 18 and 7 16ths.
I'm going to start writing that down.
Yes, you write them down. And then we'll do 17 and, oh, what? Should we get crazy? Let's get crazy. And like, we'll do 12 15ths. There you go.
19.
Well, that's
Yeah.
no fun because nobody's gonna write 12 15ths. Let's make this 13 15ths. There you go. What's 12 15ths the same as?
Wait, I'm doing a 13 and
yeah,
a
just
19
for fun,
one
just
first.
an aside. What's 12 13ths, or excuse me,
I'm doing the
12...
13 and the 19 one first.
Wait. Before you get there, just one fast one. What's 12 15ths?
12 15s, it is 180.
Oh, well, if I did this times... Not even that. Wait a minute. What's 12 times 15? I'm saying, can you reduce this fraction?
Yes.
Can you see that 12s are made up of what? Numbers are made up of other numbers.
3s.
3s. Can I get 15 made up of 3s?
Yes.
How many 3s in 12?
4.
How many 3s in
5. 4. 5.
There you go. So this is the same thing as, isn't it?
Yeah.
That's why I didn't put it over here as 12/15ths, because nobody's going to write 17 and 12/15ths. They're going to write 17 and 4/5. So I made it 13/15ths because 13/15ths can't be reduced.
I can't.
You can't reduce 13/15ths.
You can't. I said I
Oh,
can't.
I thought you said you can. And no, you can't. But all right, fine, good.
If
Right.
it was fractions, it would become the next would become 26 and 30.
Okay. Oh, I like it. I like it. You're right. All right, go ahead. Do these. Because you're right. 13/15ths is the same thing as 26/30ths. But yeah, all right. Anyway, go ahead. Do these.
I am.
You are doing a fine job. Look at all the math he does on the side.
47.
No stress and no fear.
47. 133. Okay. 133 is the numerator. And then 13 is the denominator.
So let's see here. 190. I have a problem. 100.
Huh.
Okay, so it's 190. 10. What's 3 times 19?
3 times 19. 3 times 9. 13 times 19 is.
No, there's 3 times 19. Just 3 times 19.
Completely.
Yes, you're correct. That's why I was making you do it in parts. What's 3 times 19? Just answer the question.
I think the denominator was right.
You got the denominator part right.
I did.
You did. But what's
It's 200. It's 247.
Can you please tell me what 3 times 19 is?
3 times 19 is 30 and 27. 59. 57.
57. You could have done 3 times 20 and then take away the 3, but okay, it's 57. So yeah, you got 147 there, and then you got to add 6.
I said it's 247 plus the 6.
Wait a second. How do we get up to 200? Oh, because it's 190. You're right. All right. So okay, wait. So we got 190 and 57, which is 247.
That's what I said.
All right. And then what?
And then the 6.
Which is?
253.
All right. Now we're good. 253 all over 13. All right. But you did get that part right. So, accentuate the positives. All right, next one.
Next one is 18.
Times 16.
Plus 7 and 16.
What's 18 times 16?
Oh wait, I'm writing it down there. Now, 10 times 10 equals 100. 60 plus 6 plus 8 equals
I would do the whole thing at once. How about just doing... Okay, sorry.
6,
You're doing the whole
6 times 8 equals 48. So that's 100, 140, and 48. 248.
10 times 18 is 180. 6 times 18
Is 60 and 48. Well, no, wait.
I like it. It's 60 and 48.
Oh, 324. No. 288.
288 so far. And then what?
And then
the 7.
294.
290.
Wait, I need to check what I'm wrong.
Hold on a second. What's 8 and 7?
What?
What's 8 plus 7?
Oh, the 7. 15.
There you go. So, what am I going to add?
188. 195.
There you go. Good job.
Wait, I need to check what I did wrong in my multiplication.
Okay, look over your... Sure, well, hold it up to the screen and I'll point it out to you.
Wait, oh, I figured it out.
Right there.
My multiplication was not wrong. I just forgot the numbers before I said it. I said different numbers than I was supposed to.
Alright, one more.
Roll.
17
That
times
makes
15.
total
That
sense
should be
now.
super easy. I do. I like the fact that it makes total sense now. Now see, same, and then we could go backwards. How many 13s and 253? Well, 19 and 6 13s. How many 16s in 195? 18 of them and 7 16s. Basically, this is just, all we're doing is division. I mean, let's think about this. All we're doing is division, right?
Yeah.
And the numbers are just, I mean, look, wait, watch me. I'm lazy though, so I'm just going to put 19. And then there's going to be a remainder of 6. Watch me.
That's a way to do it.
Right? That's all we're doing.
Yeah.
We're just writing it out differently because it's fractions. This is division.
Yeah,
but it's the same thing.
It is the same thing.
It is exactly the same thing. And instead of writing it like this, we're just saying, all right, I mean, can you see it? Can you see how the numbers work out?
Yes.
There's this and this. We just flip it. Boom.
Yep.
Whenever it's counterclockwise, you know there were naughty people involved. Anyway, all right, so go. Keep going.
I just started writing it.
Okay. What's 15 times 17? That's one you should know.
Wait. There.
In fact, you should know all of these, but that's what I mean. You knew your 20 by 20 matrix, and none of these would be hard.
255.
So let's see, 170. I'm just doing the parts.
Plus 13. 255 plus 13.
You said 13.
200.
Wait a minute. 170.
268.
All right. I believe you. So 170. And then that's the 10 times the 70. Then 5 times 17. What's 5 times 17? 50.
5 times 17. 50 and 35. 85.
There you go. So then I'm going to have 155, right? Or excuse me, 255. Got to carry that 1.
I'm right. And then the 13, which is 268.
Done.
So I'm right.
Yep, you were right. All over 15. That's a beautiful thing. Okay. Let's move on and just do one quick thing where I think you've got these wired personally. Oh wait, I'm gonna do one more thing. Do me a favor and write this out. 15 into 268 works out to be 17 with 13 left over.
Okay, so 15. Wait, I can't see it. Like some of it is blocked.
Oh, is it off the screen? How's that?
No, it's not. There, now it's better. It wasn't off the screen. It's just my little rectangle is blocking some of it.
Oh, okay.
That I can see my face in.
This over here was me explaining some chemistry and the fact that the shell model is incorrect even though we still use it.
Wait, what number's inside 268?
Yes. Which is just this times that is this, but you gotta add that to get the whole thing.
Yeah, and then 17 is there. What's next to 17? 27?
Remainder 13.
What was on the right? What is on the left of 17?
Where?
You see the 17? No, that 17 in the green.
Okay.
Yeah. What is on the other side? That's not the side that's not on the 15 side. What was on the other side?
This?
Yeah.
Remainder 13.
13?
Isn't it?
Oh, it's a 13. I couldn't. It doesn't. It looks but not.
Well,
like
would
a
it be
13.
anything other than 13? Even if it doesn't look like a 13?
No.
Okay.
But it kind of looks like 23.
I had this very... I don't know how you got 23 out of that, but alright.
No, it's gonna be 13. It just looks like 23.
Okay. So, do we need to do more? We did 6 of these. We could probably do a whole lot more of these, but I mean, you got it down. We'll practice more next week. Let's do something else.
Yeah.
I know you wanted to do it to the end of the class, but I mean, I think we beat this horse hard enough.
There's not much time left.
I know. On top of everything else, there's not much time left. Alright, so now. Your mom taught you how to do fractions. Let's explain it to you. Let's say I have, and I do, because I have it right here in my hand, 1/2.
Yeah.
So this could be a box of cereal, this could be a cup of water, this could be anything. It's got like half of something. In this case, it's half of my square. See that half? Got a half.
Technically, it's a rectangle-ish.
This is a rectangle, but the whole thing is a square.
Yeah.
Alright, now let's say I have a half, but I don't want a half. I only want 1/3 of my half. So I have 1/2. And I could put all the, well, I'll tell you what. I could put this in there, because I don't want to use this, because that could be algebra. I could put a star in there. I could put, there's all manner of things, but I'm just going to do this. I put these numbers next to each other, that means multiplication. If I do parentheses. So if I put parentheses like 2 and then 3, that just means 6. But this tells you a very specific rectangle. It doesn't tell you that it's this kind of rectangle. It tells you that it's a rectangle where one side is 2. So it tells you that it's across 2 and up 3. So I could do it like that, or I could say I have 2, and that's what this really says, 2 taken 3 times. So yes, you're just doing multiplication. Now watch me do the multiplication when it comes to, see it? 2, 3 times? What does that say? That says 3 2s. Not 2 3s, that says 2 3 times, and that whole thing is 6. Alright.
So the answer is 1/6, I think.
You are correct. You are absolutely correct. Now watch.
This is the easier version.
This is totally easy. But I'm just showing you what happens. Look, what does it say? It says to go over 1 of 2. You see that I went over 1 of 2?
Yeah.
Now what does it say? Do I want to go all the way up 1? No, I go up 1 of 3. Well, let's see, I gotta bust it into 3 pieces, and then I'm only gonna go up 1. See it there? Oh, no, wait, let me get my full manual dexterity going up. And now, I'm looking at just that one part right there.
Yep.
See it? And what do I have? 1 out of 6.
Yeah. There's a harder version where you have to like cut stuff that's common in
there. There is no harder version than multiplication. That's it. That's all you do. You multiply straight across. And this is what confuses kids because they think, well, if you can multiply straight across, can't you just add straight across? So if I want to do 1/2 plus 1/3, oh, I can't do that, right? I'm not just going to get 2/5. That's crazy talk.
That's wrong.
That's wrong. But if I have multiplication, I can because I get 1/6. But this is why I'm going over 1 up, right? I'm going over 1 of 2 and up 1 of 3.
Yes.
All right.
I think there's time maybe for one more problem.
Yeah, technically we're out of time, but let's do one more problem anyway. All right, so.
We have 3 more minutes.
Okay, fine. Let's do 3.
No, 2 more minutes now.
All right.
2 more minutes.
So I'm going to go over. Can you do me a favor and draw this one, fast one?
Sure.
I want to go over 3 of 5. So let's see here. I'm drawing it here. Got my thing here. I got to make this into 5 parts. 1, 2, 3. Do you see I'm 3 of 5?
Yeah.
Now, how far up should we go? Let's do two.
How far up?
How about just 2/3?
Wait,
How about 2/3 just for fun?
You've done.
Now, so I'm going to bust this into 3 parts. 1, 2, 3. And then I'm only going to go up 2 of the 3. So I'm going to go over 3 of 5, and then I'm going to go up 2 of 3. So that will be this, this, this,
We're still
this.
drawing. There.
What do I have?
You have 1. 9.
How did you get to 9? How many do I have?
6.
Of?
15.
There you go. Done. Now, here's a little problem. 6 of 15, I recognize both numbers can be divided by what?
6 and 15 can both be divided by 3.
There you go. How many 3s and 6?
2.
No fun. This is no fun. We got to get back to 1.
Yep.
Okay, so then I'm going to have 2. What? Actually, I got wrong. If I divide this by 3, I get 2. If I divide this by 3, I get what?
I'm still drawing it.
Okay.
There's 15. Five, then cross out 6.
I'm going to have fun in a second here. And then we're going to call it a day. How many... Man, I'm waiting for a long time here. How many 3s and 15?
Okay, done.
Great. How many 3s and 15?
3s and 15. Why 5?
5. Now watch me. How do I get 2/5 out of this crazy picture? Well, let's see here. Can you count? Can you see that our 1 is the thing that we divided by was 3 over 3?
I see how you got it. I see how you get it. 6 divided by 3 is 2. 15 divided by 3 is 5.
There you go. Now, look over here. There's 1. There's 2. Right?
Yep.
There's 3. There's 4. There's 5. 1, 2 out of 5. 2/5. You see I just changed my thinking here? And every time I got 3 of them together, I called that 1?
Yes.
Ooh. You see it? Take a color pencil and do that. Here, in fact, I'll do
I don't
red.
think I have a colored pencil in this house.
All right, fine. Anyway, see, and if I had my blocks out, we'd be able to do it. But there they are. There's the magic, by the way, for those of you that are Mortensen math people. Right here, there it is. That's a 1, right? So there's 1 of them. There's 2 of them out of 5 of them.
You're just if you made I understand what you're saying.
Yep, and then we started off by 3 of 5 and 2 of. All right, we're just playing with math.
Yep.
All right, I will see you. I like it. I will see you in a week.
Yes.
All right. You have fun today?
Yes.
All right, good. I'm glad you had fun. I had fun too.
I think we're gonna see each other next week. I'm not sure. We might be flying.
Okay, if you're flying, let me know.
Yeah, I think I'm gonna ask my mom. She said we're not gonna, but we were gonna look at it. I think.
Okay, we'll see if it works out. All right, CrewtonRamone'sHouseOfMath.com for more.